All right, this is the second video where we are looking at resistance simulations, and we have one here that kind of looks at different factors of a wire that may change its resistance and therefore the flow of current through the circuit and whatnot. So R stands for resistance, okay, and we have L here, which is the length, and we have A, which is the area, which is another way of essentially saying how thin or thick the wire actually is. So when we say area, we're talking about this surface area at the end of the wire here, which is just a measure again of how thin or thick the wire is. So just watch what happens to the size of the lettering here as I move these dials here. So if I increase the length of my wire, you can see here that the resistance of our wire has gone to 2.37 ohms, and the letter R has gotten large as L has gotten large. If I do the opposite, I decrease the length of our wire till it's really short. You can see now the resistance of our wire is 0.29 ohms. L has gotten really small, and so has R. So that means that R and L, the resistance of the wire and the length of the wire, are directly connected to each other, or directly proportional is the way that we would say it. So as we increase the length, then the resistance goes up. As we decrease the length, the resistance goes down, right? And that has everything to do with essentially the number of atoms and particles that the electrons have to pass through as the electrons move from one end of the wire to the other. Now let's look at area, surface area, or basically how thin or thick the wire actually is. So low surface area is a thin wire. High surface area is a thick wire. You can see now the size of the R and the size of the value of the resistance in ohms up here at the top changes as I change the thinness and thickness of the wire. So a thin wire has a large resistance. I mean, look how thin this wire is. We've got 10.4 ohms. All right, so think of you trying to crawl through a very narrow tube. It's going to be difficult. So that's a higher resistance. As I increase the surface area and the thickness of the wire, then the resistance goes down to 0.42 amps. So resistance and the thinness or thickness of the wire are kind of what's called indirectly proportional. So as one goes up, the other goes down. So a thick wire has a low resistance. And again, think of you trying to crawl through a large tunnel, or to walk through a large tunnel. Real easy to do compared to the real narrow one. So a thick wire has a lower resistance compared to a thin wire. All right, we'll see you in the next simulation video.